Hello, you're welcome back to my channel, Physics with Chaos. In this lesson, we are going to consider electric current. You're welcome back. Electric current. Electric current is the flow of charge per second. By charge, I mean the flow of electron. Charge will flow from the positive terminal of the battery to the negative through a component. This is called the conventional current. But in reality, charge flows from the negative side, okay, because it is an electron, through to the positive terminal, okay. This is actually called the actual flow or the direction of electron flow, okay. But mind you, or take note that we use the conventional current, okay, instead of the electron flow. If I represent the current in amps or ampere, Q represents the charge in coulomb, T represents the time in seconds, then current can be expressed mathematically as I equals to Q over T. Okay, now we have Q over T here, which can be expressed in a triangle form here by putting Q at the top and T below, okay, while I is by the side of T. If we are to calculate for the charge, all we need to do is to multiply the current times time, okay, or simply express Q as the subject of the formula, okay. Now if we are to calculate for T, we express it this way, Q over I, or make T the subject of the formula from this basic formula. Calculate the charge passing through a device when a current of 0.5 amps flow for 3 minutes. In this case, we use the formula Q equals to I times T. But then we need to change 3 minutes to seconds by multiplying it by 60. So in that case, we have our charge as 90 coulomb, okay. 0.5 amps times 180 seconds, that will give us this. Question number 2. Calculate the current flowing when a charge of 120 coulomb flows through a device in 80 seconds. Here we use our basic formula I equals to Q over T, and that gives us 3 amps. Okay? A circuit. Current can only flow in a conductor if there is an uninterrupted path for it to flow, which we call the circuit. That means a circuit must be completely closed for current to flow. A circuit is a complete path, closed path, that electricity flows through. A simple circuit has the following components, the basic components: a cell, lamp, switch, and wire. These are some of the basic things we can find in a simple circuit. Okay, if the switch or the handle of the switch, for instance, is replaced with an insulator, let's say a plastic or wood or polythene rod, then current will not flow. This shows that current can only flow through a conductor, okay. But if it's replaced with a conductor like iron, copper, aluminum, or silver, then our bulb will light up, showing that current is flowing. Circuit symbols. Circuit could be quite complicated and can take too long to draw, especially maybe you've asked to draw all a circuit with all the symbol with all the components. Like you're asked to draw a circuit with a switch, a lamp, a fixed resistor, and all of that. It could be very complicated. Now, for this reason, we use circuit symbols to represent the actual components. Okay, this is a symbol for a switch, closed switch, and a symbol for open switch. This is a symbol for a lamp. This is a symbol for an adjustable or variable resistor. This is a symbol for a fixed resistor, a symbol for ammeter, a voltmeter, and so on. These are the symbols for different components. This is a symbol for buzzer, and this is a symbol for a motor. Okay, take note that for a battery we have a combination of more than one cell. Okay, so we tend to combine more than one symbol here for a cell. Other symbols are a thermistor, that's a symbol, grounding or earthing, there's a symbol, a fuse, inductor, an LDR or light dependent resistor, and so on. Using symbols to draw circuit diagram. Now it's easy when you use symbol to represent circuit diagram. Like what we have here, we can simply represent them using symbol. This line represents the wire. Here we have a battery or two cells, and we have this to represent. Take note that the positive terminal of the battery must be in line with your symbol. Your symbol must be representing the correct direction of flow. Okay, and then the lamps, we have two lamps here represented by this, and then we have a switch represented by this, an open switch. Okay, now you can pause the video at this point to try these two. Okay, try and see if you can actually represent the circuits here using symbol. Types of circuits. 1. A series circuit. A circuit with only one loop is a series circuit. The components, like the lamps here, are connected end to end. Now even the switch is connected end to the end of this lamp here using a single loop of wire. Okay, some of the features are: one switch is just enough to control the entire circuit, control the flow of current. Okay, and when one lamp breaks or dies, the other one stops working. This is because there's a gap created in the circuit, and once gap is created, current cannot flow. Electric resistance increases as more components are added. So this makes the lamp or the lamps to become dim. Like in this case, if I should add one more lamp here, the overall or total resistance in the circuit here become bigger. That will make the lamps to be dim. Okay. Number 2, parallel circuit. A circuit that has more than one loop is a parallel circuit. The components in this case are connected side by side, like what we have here. Okay, some of the features are: each loop can have a separate switch to control the lamp or components in the loop. For instance, I can have a switch here. I can even have a switch here to control just this lamp here. Okay, I can even have a master switch that is connected close to the battery or cell to control the entire components. When one lamp dies, the other one will continue to work. This is because there is still a path. Let's assume this to be a closed switch, and there will be a path for current to flow through the circuit if this lamp here stop working. The electric resistance decreases as more components are added. Now recall that I said earlier that the resistance is going to increase for series circuit if you keep adding more lamps or more components. But this is opposite to that. When you keep adding more lamps, the resistance, the overall resistance, will tend to drop. Okay? This will make the lamp, the brightness, not to be affected, or the flow of current to be increased. Okay? The problem here is that it will run down the battery or the cell on time. Number 3, short circuit. An electric circuit that allows a current to flow or to travel through an unexpected path, or the shortest possible path, is known as a short circuit. Some of the features of short circuits are these. There is a direct connection between the positive and negative terminal of the battery. As such, current takes the shortest path back to the battery. Okay, now you should know that current will always want to flow through the shortest possible path, to always want to take the shortest possible path. And if you provide one, let's say using a conductor, instead of having a single loop here and then you just use a conductor to connect these two, it simply flows through the shortest path, leaving this bulb to be not to light at all. Okay, a short circuit can be created when a conductor or a liquid interferes with a series or parallel connection that you've made already, creating a short path that current can flow back to the battery. This is exactly what happened when your phone falls in water. Okay, when your phone falls in water and it's still on, water creates the shortest path for current to flow in the circuit board. Okay, and that will have an adverse effect on your phone. The current flowing is high and electric resistance is low, since current does not flow through any circuit component. Remember, the circuit components are there to either decrease or increase the electric resistance. In this case, current is not flowing through any component, so it will be high. Okay, since the current flowing is at high level, it may lead to heating effect, causing damage to electric components, or can even start a fire outbreak in residential and commercial buildings. Describing electric circuit using models. A model is a helpful way of thinking about something that you cannot see, or that is too big to handle or too small to handle. So a model is simply a physical representation that shows what something looks like and how it works. Okay, in modeling electric circuit, we should take note of these facts here. This, for instance, is a simple model of an electric circuit, but in modeling electric circuit, these facts must be taken, must be noted. Charges are not produced by the battery. They are already in the wire. Remember, electrons are present in all conductors and even in insulators, but they are free to move in conductors. The battery just provides a push for the current to flow. Take note of that. And no single model can explain everything. No single model can give us a perfect explanation of what is happening in an electric circuit. Please take note of that. One of the models we have here is the rope model. The rope model. In the rope model, we have a person X that pulls the rope and then moves it in the process, while others grip the rope. You can have 1 or 2 or 3 persons gripping the rope. Okay, Now, the rope model can explain a series or parallel circuit. In this case, a series. For parallel, we need more than one rope, okay, but handled by the same person, or gripped or pulled by the same person. The movement of the rope actually represents the movement of electron. The person pulling represents the cell or battery. These guys are gripped gently and allow the rope to move through their hands or between their hands, represent the components. Okay, we can even use another person to represent the switch, someone that can just grip it hard and stop the rope from moving. Some of the features are these. With less people in the loop, X can pull the rope faster, showing that electric resistance increases with more components in a series circuit. So if you have one person, X pulls the rope even faster. With two, not too fast, and so on. The amount of rope going through each person's hand when X pull is the same. This means that the charge flowing per second, or the current, is the same throughout a series circuit. All the parts of the rope starts to move as soon as the person X starts to pull it, showing that the current starts to flow as soon as a battery or a cell is connected. The rope transfers energy from X to others because their hand warm up due to friction as X pulls. Okay, the faster the pull, the warmer their hands. Okay, this shows that with more cells or a battery in the circuit, more energy is transferred to the components. Okay, that's a rope model. Another model we have here is a factory model. In a factory model, the factory actually represents the battery. Let's assume that the factory produces orange drink to be supplied to a shop. The truck represents the flow of charge, or the moving truck. We can even use a bridge here, a barricade, to represent a switch. Okay, the shop here represents the components, and the fruit drink, the orange drink, actually represents the energy that is being transferred. Okay, which you're going to learn later in the subsequent lesson, the voltage. The number of trucks traveling or delivering the orange drink is the same, meaning that the same number of charge flows in a circuit. Like we have in this case, we have like 4 trucks, so the same number of charge flow in the circuit. The truck carries the orange drink, meaning that the charge transports or transfers the energy. Okay, if there are 2 shops, then the amount of orange drink loaded by the truck will be shared to the shops. This means that energy is shared in a series circuit if you have more than one component. Okay, take note, like every other model, there is a limit, okay, to this model here. Okay, the lamp in a circuit lights up, in a normal circuit lights up immediately, but in this case a truck has to move from one point from the factory to the other to get to the shop, and this is a limitation as to what is happening in a circuit. Now, the water circuit model. In the water circuit model, the pipes are like wires, and the flow of water represents the flow of charge. The pump pushes the water around the pipe, so it represents the battery. The tap, let's tap here, can close or open, so it allows the flow of water, and also representing the switch that can be opened or closed to allow the flow of charge. The meter here measures the flow of water. Okay, so it actually represents an ammeter that measures the flow of charge. Okay, the limitation in this case is that the pipe can burst and water will flow out through the opening. But in the case of a normal circuit, even when the wire is broken, charge cannot leak away from the wire. Okay, connections at home and in electronic components. Now, the electrical gadgets used in a house, such as a bulb, fans, heater, and so on, are always connected in parallel. Please, are not in series. This is because we need the other items to work when one is not working. Okay, so for that reason, all our lamps, our bulbs, other components that are used at home, like the air conditioner and so on, are connected in parallel. Okay, but there are other cases where we have series connections, like in this case here, a flashlight. The connection has just a single loop. Everything is in a single loop. The battery, the switch, and the lamp, they are all in a single loop. Okay, which is a series connection. Other items that are connected in series include the freezer, refrigerator, the Christmas light like what we have here, and so on. Guys, I believe you enjoyed the video. For more videos like this, don't forget to like and subscribe to this channel. Have a nice day.